Years ago when I was in college at the University of Virginia, my professors were telling me that the world was coming to an end. They assigned things like Silent Spring, the limits to growth, and of course the population bomb. And being somewhat naive, I kind of believed them. I was basically saying, my future is very bleak and I'll probably be dead in the next 20 years or so. Well, 20 years later, I was working for Forbes magazine and I noticed that we were still here. So I had the idea that I would go back and reread these classics and then go to the people who wrote them and ask them, how did you get it wrong? And I fully expected them basically to say, well, we got it wrong this way or that way. And it didn't work out that way. It turned out when I called up Paul Ehrlich, for example, and chatted with him and would go through the 1968 version of the book, the population bomb, he said, well, I got my timing wrong, Ron. And I go, really? So when are the famines going to happen? They're going to happen between, this was 1990 when I called him up. He said the famines will come out between year 2000 and 2010. Still hasn't happened, Paul. I went to MIT and talked to the folks who did the limits to growth, and I spent all day with them going through page by page of the limits to growth. And essentially they told me, well, all right, we overemphasized the material resources side a little too much. And I go, well, have you told the New York Times that? You're on the front page of the paper. And no. So essentially I discovered that, if you will, environmentalism was not about science. It's essentially a kind of ideology. And so I wrote my first book, Ecoscam, based on a series of articles I wrote in Forbes magazine on that. But when I was signing my book contract for Ecoscam, my editor, Tom Dunn, who is also the editor of this book, told me after it was over, he said, Ron, I just want to tell you, if you brought me a book that argued that the world was going to come to an end soon, I could have made you a rich man. I have still not been able to come up with that book. In any case, so this book. This is a depiction, if you will, of the four horsemen of the Christian apocalypse. And they're typically known as war, pestilence, famine, and death. And the good news is all four of them are in retreat. War is in retreat. If you've read Steven Pinker's fabulous book, The Better Angels of Our Nature, you will realize that we are living in a time when the chances of being killed in violent conflict are less than they've ever been in all of human history. Pestilence, thanks to vaccinations and modern sanitation and so forth, our chances of dying of infectious disease are greatly in retreat. With regard to famine, the amount of calories per capita has increased from 2,400 per person in 1960 to over 3,000 per person now on planet Earth. Obviously, there's still some people who are hungry, but there's the lowest percentage of people who are suffering at the edge of hunger than in all of human history before, despite the fact our population has dramatically increased. Even death is in retreat. In 1950, the average life expectancy was somewhere on planet Earth was somewhere around 40 years, and today it is over 70 years. So all four of those are gone. So I've structured my talk. Whoops, don't have a very heavy hand on this. All right, back, there we go. Why are you doing this? One? Okay. Anyway, I couldn't come up with a better way of doing this, but I'm saying the four horsemen of modern abundance: peak population, peak farmland, peak pollution, and peak nothing. So let's go to peak population. This is the aforementioned Paul Ehrlich. This is what he said in 1968 in the population bomb. And basically, there were going to be hundreds of millions of people starving in the 1970s. That didn't happen. Nevertheless, this is Paul. He's still out there, still writing. And in 2013, in the Proceedings of the Royal Society B, he wrote the following. The human predicament is driven by overpopulation, overconsumption of natural resources, the use of unnecessarily environmentally damaging technologies, and socioeconomic political arrangements to service Homo sapiens aggregate consumption. And by socioeconomic political arrangements, he means free market capitalism. Do not doubt that. All right, back there, okay. So what did happen? So instead of starving to death, what happened is that total fertility rate on planet Earth has been declining rather steeply. In 1970, the average woman on planet Earth had about 5 children, and it's now down to 2.45 and continues to drop. Conventionally speaking, people often refer to the data that's put out by the United Nations every 2 years on demographics. And what you find is that typically everyone treats the solid line, which is the median projection, as the more likely one. But as it turns out, as we see, the bottom line has been the more likely. And if that continues, if that trend continues, world population will top out in the middle of the century between 8 and 9 billion and begin declining. Really? Okay. One more? No? Okay, there we go. This is some work done by demographers at the International Institute for Systems Analysis, where they've looked at UN projections and so forth, and what they believe is likely to occur is the bottom line. Again, world population topping out at around 9 billion in the middle of the century and beginning to decline. And they again find that the low variant seems to be the one that goes. And why is this happening? Largely because as people get wealthier, they have fewer children. And what you find is exactly that relationship here. In places, unfortunately, like Mali and Niger, which are incomes below, do it that way. Okay. People in Mali and Niger women still have about 7 children per capita over the course of their lifetime. Whereas if you find it, when it gets to around $10,000 per capita, it goes to below replacement. In fact, every one of the OECD countries except Mexico, and Mexico is on the verge of that, already has total fertility rates below 2.1, which is the replacement rate. So what is likely to occur? This is a demographer who works at the Spanish Foundation for Science and Technology, again, showing that the lower trend is the more likely trend. And this is a demographer at Deutsche Bank, Sanjeev Sanyal, who thinks that in 15 years, basically we will have achieved a replacement rate for the globe of 2.1 children or below. And so the population will begin declining. I believe that those are the more likely trends, and I discuss why that is the case. But it's largely the case because one of the things that we do know is that as women become more educated and have more opportunities in market economies, they have fewer children. Also, the trends to urbanization as well. One of the interesting features of people like Ehrlich, the goal of almost all species is basically to turn more food into more offspring. Humans don't do that. The places that have the greatest food security are the places with the lowest fertility rates, and the places with the greatest food insecurity are the places that have the highest fertility rates. So it's quite the opposite then. So, does everyone know who this man is? Who is Norman Borlaug? He is the father of the Green Revolution. I had the great privilege of getting to know him in the 90s and the early part of the 21st century. He's a great man. He is the person who probably saved the most human lives of any person in the history of the world by doing the Green Revolution. He essentially was enabled a process whereby the world was able to triple food supplies while the population doubled. So it's likely to occur in the future. This is Jesse Ausable. He's the director of the Rockefeller University Human Environment Program. And this is from some research they published back in 2012. They believe that we are on the verge, if not already at, peak farmland. Essentially, crop productivity is going to get even more efficient over time, that they believe that by 2060, an area, at least the area the size of France, or twice the size of France, will be returned to nature, that farmers will abandon that many fields. In fact, he also says if we could just get rid of biofuels, it'll be even vastly more than that. It would be an area twice the size of the eastern United States would be. But the biofuel problem is a problem. As I mentioned before, this is what happened. Yields basically for our main grain crops tripled since the 1960s. What you find is that you find here is the yield gap. It is, people are saying we don't have the technologies to increase yields, but the point is that the United States yields are about 10 times higher than yields in Africa still. Those technologies still need to be deployed around the world, and we can, using current technologies, no miracle technologies, what we already know, to dramatically increase yields. As I mentioned, the amount of calories has been going up since the 1960s to today. And because of the peak farmland phenomenon, because we have so dramatically improved productivity on croplands, this is what the difference is. If we had been stuck at 1960s levels of productivity, we would have had to plow down 3 times as much land as we currently use for crops. This has been decoupled, and basically the amount of cropland has gone up just a little bit since the 1960s to supply those 3 times more food today than we were producing then. What would have happened if we'd had to do that is what is referred to as Skinhead Earth. We would have had to plow down pretty much all the remaining forests on planet Earth. Even then, it probably wouldn't have worked, but that is the amount of land that would have had to be used. The area of USA, Canada, China, or almost twice the size of South America, if we had been stuck at 1960s levels of productivity. As a result of our increasing productivity, the forests are returning in most places. Unfortunately, in misgoverned places like Indonesia and Brazil and the Congo, we are still finding rainforests are being cut down, probably unnecessarily so. The good news is that plantation forestry, Roger Sedgwick has estimated, you could grow all the wood that we would need for everything, paper, building, whatever we need it for, on about 10% of the world's forest land. And we're moving in that direction very rapidly. And that would, again, spare wild forests from being plowed down or used. Part of the reason that this is going on is what is called the environmental Kuznets curve. As countries become richer over time, they start demanding a cleaner, better, richer environment. What happens is the notion here is that poor people, when they start economic development, the process of economic development, they're not overly concerned about air quality or water quality. They're more interested in getting food on the table, getting their kids educated, getting a better house, basically getting better material life. But at a certain point, when they get rich enough, they look around and go, I really don't like the crap in the air and in the water. And they begin the process of technological improvement and environmental improvement where things get better. Basically, the line is that anything that slows down economic development will slow down eventual environmental cleanup. Richer is cleaner. Richer is not dirtier, richer is cleaner. And as a brief bit of evidence for that, here is some data from the EPA. And the EPA cannot be wrong, so it must be the case. What you find is for air pollution trends in the United States, there are 6 criteria pollutants that are now they have carbon dioxide, but before that, there were things like sulfur dioxide, carbon monoxide, and ozone that are regulated by the EPA more or less efficiently. And what you find is that as the economy doubled in size, as vehicle miles increased by over 150%, energy consumption, population, and CO2 emissions all went up by 50%, the air pollutants went down by 60%. Richer is cleaner. The vexed question of global warming. What is going on with that? This is data comparing the satellite and surface data trends over time. And basically there are 3 surface data that are mostly relied upon. These are basically series that are set up using thermometers on land and thermometers at sea, if you will, trying to figure out what the temperature was over the last 150 years or so. And then the satellites have been up monitoring the temperature of the globe since 1979. And so this is a comparison. And what you find is out toward the, if you will, the end there, as we get closer to 2015, is that it's kind of flattened out. This is the famous hiatus. Temperatures have not been going up as fast as had been projected. Well, this, unfortunately, annoys some people. This is the results of a new study put out by researchers at the National Oceanic and Atmospheric Administration, where they basically find that there's been no hiatus. And the way that they found this is they went and rejiggered the temperatures, the ocean temperatures, to increase. And the way they did that is a very interesting way, and there are some people questioning it, is they took very accurate data from the series of automated buoys that are traveling the oceans. It's very accurate on that, and they've only been out there 10 or 15 years. And then they increased it based on the fact that they thought the old crappy data from ships and so forth was better. So making better data worse is how you get this trend, is one way of putting it. It's very creative science, and we'll see if it stands up. This is I tend to rely on the folks who do the satellite data at the University of Alabama at Huntsville, and what they find is that the temperature of the globe is increasing at 0.1 degrees Celsius per decade over time, which is not a lot. The IPCC, the Intergovernmental Panel on Climate Change, is tried to compare the models that they have with the actual data from various groups, the satellites and so forth. And Christie, who is the guy from the University of Alabama at Huntsville, has done the same thing. And basically what you find at the bottom there is the satellite data and the balloon data. And what you find is that the model data the models are running much hotter than the actual temperatures are at the globe at the moment. And he makes this much more clear schematically. The models are running too hot. The folks at University of Alabama at Huntsville are not the only people. Another group called Remote Sensing Systems has found the same thing. This is their comparison of the data. And again, you find the yellow areas, the model projections of where temperature should be. And what you find is at the bottom, the thick line, the actual temperature data. And that's also the case for the tropics. And though they do find that the models are more or less accurate with what is happening at the North Pole. We can discuss global warming during the question and answers. Peak everything. Is the world running on empty is the way I put it. This is Richard Heinberg. He works at the Post-Carbon Institute. He's written a book called Beyond the Limits of Growth. And as you say, the world is at, nearing, or past the points of peak production of a number of critical non-renewable resources, including oil, natural gas, coal, as well as many economically important minerals ranging from antimony to zinc. He's not alone. Remember peak oil, everybody? Yeah, very popular. The German-based Energy Watch Group released a report in 2007 that basically said that oil will drop 3% a year from now on and will be half of what it was by 2030. And this will create war, famine, pestilence, and what have you. In fact, Kenneth Defees at Princeton wrote a book on peak oil. Herbert's Peak is what he called it. And he actually said oil peaked on Thanksgiving Day, 2005. As it turns out, in 2005, the average amount of oil, the daily production of oil was about 83 million barrels per day. It is now 93 million barrels per day as of this year. It certainly didn't peak. This is Leonardo Mulgari, who's at the Belfer Center, who's an oil man, who has made this projection, which I think is likely to be the case, that we will be up to 110 million barrels, up from 93 million now. And as we all know, the prices did go up. We were part of a super cycle, and the prices did go up. But I was listening on the radio this morning. It's now below $49 per barrel. It's fallen again. Now, I do discuss in the chapter what super cycles are like. The idea here is that some economists believe that they've been able to identify, if you will, waves of economic development, whereby various parts of the globe start rapidly improving their economic situation, the United States and Britain in the 19th century, Germany and Japan in the 20th century, China most recently. And what happens is the demand for all kinds of commodities goes up very, very rapidly. And the prices, of course, start going up. And the argument is that we're going through the up phase of a super cycle during the beginning of this century. And the argument is, and it's very hard to always pick a peak, but the argument is now that China's economic growth rate is settling down and so forth, that the commodity prices should start descending. And in fact, they are descending. Interestingly, after every other super cycle, the price of commodities was lower than the last trough, the preceding super cycle. So we'll see if that happens. But in any case, this is the limits to growth. They have a very helpful little chart in the middle there, which would tell you how long known reserves of various minerals would last. And what you find is, in 1972, All of these things were supposed to be gone basically by the year 2000, of known reserves. They did, in fact, do a 5 times analysis, assuming that you could find 5 times more, and it should last a little bit longer. But this was the main prediction. This is I hope people will recognize this gentleman. This is Julian Simon, one of my great heroes. He's wearing the horns because he decided if they're going to demonize me, I may as well look like it. So, in any case, I go through the U.S. Geological Survey, known reserve estimates, and as you can see, there's plenty more coming. We have plenty of supplies. Now, what people tend to forget is that we don't, miners and developers don't go out and try to find every last reserve. You find it as you need it, as prices signal that you should find it, spend the money in the investment on it. So these horizons, if you will, for all these reserves tend to just be maintained at about this level every year. It remains the same. You can go back from the U.S. Geological Survey, and it's very similar to that throughout. I may as well, let's go back to the Simon. I assume that most people know the Simon bet, but I'll recount it here. In 1980, Simon and Ehrlich bet on 5 metals and what their prices would be. Ehrlich was convinced that their prices were going to go way up, and Simon said that by 1990 they would be down. In 1990, Ehrlich and his colleagues sent a check to Simon for, I think it was $567.07, which meant the prices had gone down by more than 50%. But you have to be careful about that. These super cycles can mess you up. If Simon had made the same bet, let's say in 2003 to 2013, he would have owed $2,500 to Ehrlich. So you have to be careful about that particular thing. But the question is, has the latest super cycle peaked? And I looked at some of the metal prices here, and you can find that they are now about 50% lower than they were during the peak years that are listed there. And this is a commodity price index chart just from earlier to this month from the IMF. And what you find is, again, a lot of them are back down to where they were at around 2,500. And the question is, will they go back to where they were at the end of the 20th century? My bet is that they will. We will find out. So I think the right question is it realistic to predict that knowledge accumulation is so powerful as to outweigh the physical limits of physical capital services and the limited substitution possibilities for natural resources? Basically, is human ingenuity sufficiently productive that we will never run out of anything that is a critical resource, that we will find ways of substituting it? I think the answer is yes, and I hope I make the case very strongly in the book that that is the case.